Students, in today's class we are going to talk about Arrhenius concept of acids and bases. In the ionic equilibrium lesson, it is one of the important topic. We have to learn about the concept of acids and bases, which is given by Arrhenius. So what is called an acid according to Arrhenius concept? Acids are the substances which can give replaceable hydrogen plus ions or hydrogen atom in their solution. Very simple. What are all the substances which can form hydrogen plus ions in their solution are said to be acids. Just for example, if you take hydrochloric acid, HCl, in water, then what happens? It can give H plus and Cl minus. When the H plus is added with this, we will be having H3O plus and Cl minus. So the hydrogen plus is provided by this hydrofluoric acid. Thus formed hydrogen plus is combining with H2O to form a hydronium ion. This is the ion called hydronium ion. So the hydrochloric acid is forming hydronium ion with the water, and hence it is an acid. Likewise, if you take nitric acid, HNO3, if it is in contact with water, this can give H plus and NO3 minus. The hydrogen plus will get electron from this. Otherwise, we can add the hydrogen plus to the water. So the result will be the hydronium ion and other will be the NO3 minus. So it is also providing the H plus. The substances which are forming hydrogen plus are generally called acids. Likewise, if you take H2SO4, when it is in contact with water, it has got two replaceable hydrogen atoms, so that we can have 2 times hydronium, H3O plus, and other would be SO4, 2 minus. So the acids are the substances, they can form replaceable hydrogen atoms or replaceable hydrogen ions. You just see the sulfuric acid, it has got 2 replaceable hydrogen atoms, and hence the sulfuric acid is simply called as dibasic acid. Why this is called so dibasic? Dibasic means the number of replaceable hydrogen is equal to 2 means it is dibasic. The number of replaceable hydrogen atom is equal to 1, you can call it as monobasic. So these are the 2 monobasic acids. Monobasic, as they are having single replaceable hydrogen, but sulfuric acid, it's a dibasic acid. So this is about the concept of Arrhenius for acids. Okay. According to Arrhenius concept of acids and bases, what are called bases? Bases are the substances which can give replaceable OH minus ions in their solution. So what are all the substances which are giving replaceable hydroxyl ion in particular in their solution are said to be bases. So we can have an example. The sodium hydroxide is a substance, NaOH. If it is taken in the form of its solution, it will be giving you Na plus and OH minus. The hydroxyl group is obtained. The number of replaceable hydroxyl group can be called as acidity of a base. Here the acidity of this sodium hydroxide is 1. so that we can call this as monoacidic base. Sodium hydroxide is having only one replaceable hydroxyl group. Likewise, we can have KOH. If it is converted into its own solution, in the solution form, it can form K plus ion and OH minus. So the hydroxyl group is again obtained. This is also said to be monoacidic base. Consider the calcium hydroxide, CaOH twice. When it is converted into its own solution, that will be giving you Ca2 plus and 2 times OH minus. Here we are obtaining two replaceable hydroxyl group, and hence it is said to be diacidic base. You can have plenty of examples for this category. Even when you take the aluminum hydroxide, AlOH thrice, if it is in the form of its solution, that will be giving you Al3 plus ion and 3 times OH minus ion. Hence it is said to be triacidic base. So according to the Arrhenius concept, acids are the substances which can form replaceable hydrogen ion. The bases are the substances which can form replaceable hydroxyl ion. Is it clear? So Arrhenius concept failed to explain certain acids which are not containing the hydrogen plus and certain bases which are not containing OH minus. So that is the greatest disadvantage or demerit of the concept of Arrhenius about the acids and bases. Certain substances are behaving like bases but cannot produce OH minus ions in their solution. So this kind of bases are not explained by the Arrhenius, and hence it's the greatest disadvantage. One of the example, ammonia is a well-known base, but if it is in contact with the water or if it is made into its own solution, it does not produce OH minus, but it is a base. So this is the disadvantage of Arrhenius concept. And certain substances which are normally acids, but they are not forming hydrogen plus in their solution. So in order to explain such kind of acids and bases, another concept is required. That might be fulfilled by some other concepts about acids and bases. Just for example, Lowry and Bronsted concept, and that will be followed by Lewis concept. So in our next classes, we are going to deal about the Lowry-Bronsted concept of acid base and as well as Lewis concept of acid and base. Okay.